So hello again, everybody, and welcome to our latest in our online webinar series, Structured Building Data and its Frictionless Flow. My name is Matt Henson from Dorofus, and I will host today's webinar. Building projects contain a lot of data, which means they need to be managed, otherwise it can really affect the return on investment of the project. Today, Conrad Fugas and Deepesh Stalpur will aim to demonstrate how building data can be structured with best practice to enable connected and frictionless data flow in the design and construction process.
Let's begin with the obvious. A lot of clutter morphs into chaos, both in an apartment and in a building design and construction. In a flat, we tend to sort things in wardrobes, while a building project, we can present information in what? My name is Conrad Fugas, and I'm going to guide you through the method of structuring building data. Shortly about myself, I graduated from Warsaw University of Technology in Poland in the field of structural engineering. I have 4 years experience working on a construction site, both in Poland and Norway. So getting to work at 5 a.m. because the concrete is arriving is something that is not unfamiliar to me. And same as everyday chaos on the site and unfortunately in the construction documentation. Then I started to work in Dorofus and work with clients on governmental buildings, hospitals, or schools, helping to organize and manage their data flow. Together with 5 other engineers from Poland, we started a BIM corner block, and our main mission is to spread the word about practical usage of BIM. Privately, I'm triathlonist, aiming for completing half Ironman distance this weekend, and backpacker that has just finished sitting on a quarantine. It's like stating the obvious. A lot of clutter morphs into chaos. In the apartment, maybe this is us few years back or our daughter exactly now. On a construction site, I bet this is our competitors or this chaotic and gloomy office of our boss. Such pictures can go on and on. Invoices, registers, Excel spreadsheets, etc., etc. Yeah, but you're not here to look on what does not work. You want a solution. So let me ask some questions. What can we see in that picture? Wardrobe is sorted by the garment and color. What is here? Pathways and building materials placed according to their allocation and purpose. And here, invoices grouped maybe according to the dates or contracts or some other data. And I know that for now, it may sound like making a greater philosophy out of cleaning, but let me continue and ask, what is the key here? Each picture and each thing's data on that picture were sorted out by the common parameter, either bit color, purpose, date, whatever. How can we move it into the field of BIM project? That's the question, and here's the challenge. Rooms, spaces, zones, IT families, instances, systems, connectors, coverings, categories. Building elements BIM dictionary is extensive, and you can easily get lost on what is what. And working on a project, do I even know what data do I have within a model? There are 10, 15 or more people on working and modeling. Everyone is adding data to the model. For me, sometimes when I'm starting a new project with a client and I'm looking into the model, I'm feeling like a learner on this GIF. Something is red, something is yellow, green, blue, but where is that information I'm looking for? How to find it? How to sort out building data? I know for now 2 possible ways, within a modeling software or using a database, and I'm going to describe them now. The information found within a BIM authoring tool is spatially interdependent. If an X-ray room marked on the screen is on the same floor as the offices marked above, then they are displayed together and sorted as being one big picture on one floor. And that's regardless of their different function and whether they are logically interconnected or not. X-ray might be the dental department, and offices might be administration department. Same goes for objects. We see here a lot of instances of chairs, patient beds, walls, doors, and other equipment. And their hierarchy you see on the right. There, we have only parent-child relationship as presented here in Revit. So we start from the top, the category, so just a wall. Then we go below to the family, internal wall type, internal wall 100 millimeters thick, and then instances that we place within a model. And those might be 4 partition walls that creates a room. So basically, we structure things divided on where they are on the model, floor plans, or their parent-child relationship. And such groupings works perfectly working within 3D environments. It helps modeling efficiently. But here are some drawbacks. The problem arises the moment we want to aggregate and then extract the precise set of information, such as how many different types of doors do I have, and how many instances of each type. If I change that type of wall, how many walls in total does this affect? In which rooms do I have partition walls type W01? To answer those questions, we have to each time create different schedules. And yeah, that requires a lot of efforts to achieve the desired effect. And every set of data needs different schedule. Of course, more tech-savvy designers uses Dynamo or Grasshopper to harvest requested data. And believe me, that ain't an easy solution either. So to sum up, modeling tools are pretty miserable when it comes to managing the data. But all in all, that was not they were created for. Sounds obvious? Then why so many still do that? The other possibility is to put data within a separate database. But then it comes a question, how to present them there? In modeling tools, we can easily discern and name kinds of objects. We see that a wall within a model is going to be a wall in reality. Same goes for electrical equipment, ventilation ducts, etc., etc. In a database, we do not have spatial information. We have lines of text, tables, columns, rows. Therefore, we cannot group the objects basing on how they look or where they are. Instead, we have to structure them according to the function they perform. How does it look like? So, as illustrated in the graph, we are connecting the dots, so to speak, and we begin with a general perspective and go down with the details, starting from a building. Then we go to the functions within that building, then rooms within one function, item categories within a room, items within one category, occurrences of that item in the room, and then tangible products that can be delivered on the construction site. Let me present such sorting in an example project. So we're gonna start with a building of a school with a sport hall that can serve up to 1,000 pupils. We have here some example functions. So administration, canteen, library, classes divided for 3 sub-departments, chemistry class, physics class, and some others. We have all areas assigned to them. Then we go level below, we have rooms. So rooms in a chemistry class sub-department. We have teacher's room, laboratory, 2 classrooms, storage lockers, and all in all, some with a programmed area of 245 square meters. And already now we can compare and contrast the data for rooms with the data for functions. But we go a level below to item list in the classroom for 20 pupils. We got furniture, fixtures, and equipment. We need electricity and automation, heating and ventilation, doors and windows, and finishes item lists. And yet one more level down, items. Those are corresponds to Revit types, family types, and their requirements for that particular classroom. So we got a washing station and multimedia board as an example of FF&E item list. Then we have a doors. Of course, we need the doors to get to the classroom for doors and windows item list. and those doors have their own requirements. Maybe there are needed some file requirements like AI30, noise insulation, lock fittings, access control of a specific type. One level below, occurrences, and those are the Revit instances of the items within that classroom. So since this is for 20 pupils, we need 21 desks and chairs, 24 pupils, one for teacher, one multimedia board, 6 ventilators, some electrical outlets, some lighting fixtures, and parquet on the floor. And finally, we get to the products, and those are the products that contractor deliver on the construction site, and then deliver mount into the room. So we have 20 Origo desks from a manufacturer Kinerps, and one for teacher from IKEA, product name Bekant. We have some specific chairs, ventilators, etc., etc. Those are all products that we can go and buy in the shop, and then a contractor may deliver them and attach to the database the maintenance and operation documentation that can be used during the life cycle of the project. And here it is how it looks in a big picture. So from left, beginning from the very top level, we move to smaller and smaller pieces of information to the more detailed data. Let me now give a mic and video to my colleague Deepesh Tapa, who will show you the practical example of structuring such data in a database.
Hi, Conrad, my friend, thank you very much for that intriguing presentation. You have indeed given us a great perspective on how building data can be best structured, especially from an hierarchical standpoint. I'm Dipesh Thapa. I'm Technical Coordinator for Durophus in the Asia Pacific region, and I'm here today to demonstrate how Durophus perfectly fits the bill when it comes to formulating that structured building data, hence or slash effectuating its frictionless flow. First, let's make a quick recap of the top-down or hierarchical structure identified by Conrad. What I'd now like to do is shrink and then stick the set of graphics to one corner of my screen there you can see, bottom left, just so that it somewhat serves as a legend for navigation, if you will. Now that I've got Durophus fired up, you will note that I'm using a software development headquarters for an insurance app called Usurance as an example project. First, we're going to take a look at the highest tier within the building data structure, that is building. You can see here that we happen to have 3 buildings for the project. Let's pick a building, say the Margaret Hamilton building. We're now going to step down to the second highest tier within the building data structure, that is function. You can see here that we happen to have a few functions within the Margaret Hamilton building. At this stage, I'd like to point out that functions can be customized to be whatever you like. They could be zones, departments, sub-departments, etc. In this example, you can see that I've set up as levels in departments. And you can see also, let's pick a function. When we select level 2, as an example, under level 2, we're going to choose the support department. We're now going to step further down to the next tier within the building data structure. That is room. You can see here that we happen to have 4 rooms within the function support department in function level. Let's pick a room, say the 12-person open plan office. We're now going to look at the next tier within the building data structure, that is the item list. You can see here that we happen to have 5 item lists set up in this example project, namely FF&E, doors and windows, finishes, services, and packages. Let's pick an item list. Let's say the FF&E item list. Let's step further down to the next tier within the building data structure, that is item. You can see here that we happen to have a variety of items within the FF&E item list of this particular office. Let's pick an item, say the ergonomic office chair, and even carry out the go-to item command to delve further into the chair from the item's perspective. Let's step further now to the next tier, which is the occurrence. You can see here that we happen to have a number of occurrences for this ergonomic office chair across a number of rooms within this project. If we now pick the very occurrence of this ergonomic office chair, specifically in the 12 persons office, which we were looking at earlier, you will note that there were 12 instances of that chair in that particular room. The final tier within the building data structure that we're going to step down to is product. You can see here that we happen to have 2 products as options for this ergonomic chair. If we now select each product, you can subsequently see all the associated information. Let's say we'd like to take a closer look at the occurrences of the ergonomic chair, specifically in the 12 persons open plan office. Products are typically based on occurrences, and so if we'd like to attach different products to different occurrences, we will need to carry out split occurrences. And by the way, splitting of occurrences also signifies the basis for setting up of individual assets. In order to now map out our specific products to specific occurrences, we will now simply do the following. Let's say we'd like 4 of these occurrences to be mapped to the product called ErgoHuman. And likewise, let's say we'd like 8 of these remaining occurrences to be mapped to the product called ErgoLux. The journey which I've just taken you through has been from the project to a specific building, to a specific function, to a specific room, to a specific item list, to a specific item, to a specific occurrence, and finally to a specific product, has been one of almost a choose-your-own-adventure type of scenario. In other words, this is the very path we have just taken. And yes, it does somewhat look like a pretty big family tree. So what this tells you right away is that Rofus is perfectly capable of handling an infinite amount of building data, and that too at various specific tiers, all the while maintaining the most complex data relationships across the multiple generations. With that, I'm now going to hand over the ball back to Conrad. So thank you very much for your kind attention. Cheers.
Yes, so just as a conclusion, the advantages of structuring building data in a database, it's easy data aggregation and scheduling, ease of management of the vast number of information, data is placed in the interconnected tables, and seamless navigation from a general to a detailed perspective or the other way around.
Thanks again, Conrad and Dipesh. Just remember, everybody, please keep in touch and give us ideas on themes and future webinar events, things you'd like us to cover, both at the webinars and the user groups. In the meantime, we thank you again for joining us, and have a good rest of the day if you're in Europe, and evening if you're in Australia, and keep sleeping if you're in the US. I guess that's the way to look at it. Thank you very much.